Hey guys, welcome back to my channel, and today we're going to be talking about the 5 hardest questions that come upon the SAT, non-calculator, or calculator. I have a mix of both, but I'm going to be solving these all without calculator and all shown with work. So yeah, let's begin. So let's start with the first hardest question. So in triangle ABC, the measure of angle B is 90 degrees, BC equals 16, and AC equals 20. Triangle DEF is similar to ABC, so similar means they have the same proportionality, the sides. And so also it says here that the vertices DEF correspond to vertices ABC respectively, and that each side of the triangle of DEF is 1/3 the length of whatever the side is for ABC, the corresponding side. So what is the value of sine F? So the best way to solve this problem is to draw it. Whenever I'm working with triangles, I always draw it. So I'm going to put an A here, a B here, and a C here. The reason why I put B there is because it's a 90-degree angle. And I'm going to do the same way because it's corresponding for DEF. So D, E, F, because A corresponds with D, B with E, and C with F. Now I'm just going to figure out what these are. So we say, it says in the problem that BC equals 16, so BC, I labeled it as 16, and AC equals 20. Now, before I go further, I'm going to simplify these. So if I've noticed, I can divide by 4. So I have a 5 here and a 4 here. So as you can see, it is a 3, 4, 5 triangle. Okay? So now I am going to take a third of this and this so that way I can solve this problem. So it'd be 5/3 here because it says here that each side of DF is 1/3 the length of the corresponding side. This is 4/3 and this is 1. So now the question's asking what is sine of F. So sine of F, remember sine is so in SOHCAHTOA. So is opposite over the hypotenuse. So this is sine. So it is the opposite, which is 1, over 5/3 because it's the hypotenuse, which is 5/3. Now we do keep change flip because it's division. So we do 1 times, flip it, so 3/5. So our answer would be 3/5 or 0.6. Right? So that's one of the hardest questions. Now the next one has a graph. So this is actually one of the most easiest questions in the SAT, but people consider it to be hard. But whenever you're looking at graphs or anything with graphs, I always recommend plugging in values because that's the best way to solve. So I'm just going to find a point here. So I think that's the easiest one. So it's 0, 2 that's on the graph. And I'm just going to plug it in. So if I plug in 0 here, I'm going to get 2. So this is good. If I plug in 0 here, I'm going to get 2 squared, which is 4. So obviously that's not 2, so it doesn't work. 0 minus 2 is -2, so that doesn't work either. 0 minus 2 is -2 squared, and that's 4. So that doesn't work either. So actually, this is the most easiest question, and it's A. And I can check, okay, here's another value right here, and I believe that is -2, comma, 1, 2, 3, 4, 5, 6. That is -2, comma, 6, and I can check. So -2 squared is 4, plus 2, which equals 6. So obviously, A still works. All right, so when you're dealing with graphs, you just plug in points. When you're dealing with triangles, you draw them. All right, let's go to this one. So now we're going to do a question about complex numbers. So when I'm working with complex numbers, I always try to multiply with conjugates so that I can make it easier for me when I'm solving. So I have 3 minus 5i over 8 plus 2i. And now I'm just going to multiply by the conjugate because you can multiply by the conjugate because it's just 1, right? You're just multiplying by 1, and you can multiply by 1 as many times as you want because 8 minus 2i over 8 minus 2i is 1. Okay, it's just another form of writing it. Now I'm just going to distribute. So I have 64 and then -2i because it's 8 times -2i plus 2i times 8. It's actually going to cancel, so we don't need to write that. So we just go directly into this. So we have minus 4i squared. And then we'll do the top. So we have 24. And then we have minus 6i minus 40i, which is minus 46i. And then we have plus, because -5 times -2 is plus 10i squared. Now, we can actually get rid of the I squares. So we don't plug in radicals. We don't plug in the radicals for I, but we know that I squared would equal -1 because if I square both sides here, I'm going to get I squared equals -1. So this is going to be easy now. So I just plug in -1 for this I squareds here. So I have 24 minus 46i minus 10, right? Because this goes -I, so -10 over 64 minus 4, and then the negative 1 from I squared. Now I am just going to solve, so I'm going to write it over here. So we have 68 on the denominator, then we have minus 46i plus 14. And now I'm going to separate these because there's only one denominator, so I'm going to separate them into two different fractions and simplify. So first I'll do the 14 over 68, and plus, or I can say minus 46i over 68. So before off the bat, even before we know it, we can cancel out b and d because there's no plus here, it's a minus. Now let's simplify this one. So we can divide by 2, so we get 734. So obviously this wouldn't work, but let's check if this is right. And then we have a minus, and then we can divide by 2 on the top and bottom. So we have 23, because 23 times 2 is 46, and then divided by 2 here, so it's 34. So our answer here would be C. So when you're working with complex numbers, always try to multiply by conjugates. That's the best way to solve. All right, let's go to the next question. All right, so this is actually one of the harder ones too, but people, if you read carefully, you'll probably figure it out that it could be easier. So in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. So they're trying to determine if treatment X is successful in improving eyesight. Okay? Half of the participants were randomly assigned to treatment X, and the other half did not receive treatment X. The resulting data showed that participants who received treatment X had a significantly improved eyesight as compared to those who did not. Based on the design results of the study, which of the following is an appropriate conclusion? So let's start from here. Treatment X will cause a substantial improvement in eyesight. But we can't say it's a substantial improvement because it's from a large population of people, but we only selected 300 participants. So we don't really know. It'd be better if we had a larger sample, right? Treatment will improve the eyesight of anyone who takes it. So that's kind of like a thing in SAT. When you talk about, you say every, all, anyone, those are kind of too broad, and most of the time those questions are wrong on the SAT, most of the time. So when it says anyone who takes it, we're not really sure about that because we only tested 300 participants. Treatment X improves better than all other available treatments. So we can't determine that either because we only given one treatment, that's X. We never compared it to other treatments like Y, Z, we don't know that. And then treatment X is likely to improve the eyesight people who have poor eyesight. So this is 100% true because it is likely to improve, right? We're not 100% sure, but it's likely to improve, right? We can't say it will improve. It is likely that it will improve. All right. Okay. Let's go to the last question here. So here we're just trying to find, we have a center O, and the measure of angle AOB is pi over A radians. What is the value of A? So remember, this is a circle, right? So we have A root 3 comma 1, and we're trying to find what it is. So we can draw this as the terms of a triangle, and if you draw it, the root 3 goes here, and the 1 goes here. And now let's find the hypotenuse. So it's just root 3 squared plus 1 squared equals c squared, basically the Pythagorean theorem. So we get 3 plus 1 equals c squared, and that equals 4c squared equals 4 equals c squared, and c equals 2. So we know this is 2, right? And from here, we can obviously tell it is a 90-degree angle, right? So 30, 60, 90 degree, which is kind of easy to tell because if you can use the Pythagorean theorem for it, and based on this, these are values for a 30, 60, 90 degree angle. And so we can say this is 30 degrees. So if I want to get root 3 over 1, it's basically just doing opposite. It's just doing this over this, right? Or if you want to get root 3 over 1, it's basically having this and then multiplying it. So that is what we're going to do. We are going to take the 30 degrees and we are going to multiply it by pi over 180. And when we do that, we get pi over 60. So our answer is pi over 6. Pi over 6, sorry, not pi over 60, I'm sorry. Zeros cancel, you're left with pi over 6. And 6 is your A value here. And to make sure that's right, obviously it's like if you take the tangent, it is root 3 over 1, right? And the tangent of 30 is root 3 over 1. Or you can say the tangent of pi over 6 is root 3 over 1. So it's opposite over adjacent. And this is like the value of a, which is it's a point per se on the graph. It is an x. So this is an x value and this is a y value, basically. Okay? It's an x and y value, and what we did here is we have put them now in a 30, 60, 90 degree triangle, and we have solved it the same way, x and y values. Okay, so yep, that is it. So thank you so much for watching. If you have any questions, please put them down below. And once again, thank you so much, and bye bye.